Unit, widget, and integration tests. That's the testing pyramid you're probably familiar with. The first two have always been quite easy to write and quick to execute on Flutter. However, integration tests, which are the focus of this tutorial, have had a fair share of their problems. They used to be unnecessarily hard to write and impossible to run on device farms such as Firebase Test Lab. That is, until we had the integration tests package. Hello, welcome to Reso Code, where you're getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. This tutorial is sponsored by Codemagic, the continuous integration and delivery for mobile apps built with Flutter in mind. It's incredibly easy to configure and also has 500 free build minutes every month. So go ahead and check it out from the link in the video description. Before we jump into what we are going to be actually testing in this tutorial, because the app which we're going to be testing is fully written, this is the app that we'll be testing. Before we do that, let's briefly talk about the testing on Flutter and most importantly about integration tests. So unit tests are for testing the non-UI logic of your app. Then widget tests verify the behavior of a single widget mostly. Both of these are quite low level. They even can usually test and deal with intricacies that are only familiar to developers and testers. Also, they are very quick to execute because they just run without any real app being built. They do not run on an emulator or on a device, so they are very fast to execute. Flutter's integration tests test the UI flow of the app from the user perspective. So again, they test the UI flow of the app from the perspective of a user which would regularly use the app. In fact, we could say that they simply simulate a user who is just regularly using the app. Instead of integration tests, we could, in my opinion, say UI flow tests, but we're going to use the official terminology in this tutorial. Unlike unit and widget tests, integration tests run on an actual device or an emulator. And as you can imagine, this makes them quite expensive to run, both time-wise and financially, of course. And in addition to that, they do not really deal with all the intricacies that the unit tests or widget tests can deal with. They really are just for testing the big picture of the app, just as if it was used by a regular user on an emulator, right? So while they are immensely useful in finding out about errors that affect the user, integration tests give you very little information about what actually went wrong. So that's the reason why integration tests are not enough on their own, but they are a great complement to unit and widget tests. So we are going to be testing this app, which is already fully written for you. And if you do not want to just write it yourself, but actually get the starter project so that you can follow along with this tutorial, make sure to go to the link in the video description, which is going to take you to the written tutorial, where apart from the starter project, you can also find all of the code written in this video, links to the libraries, and overall go through this lesson at your own pace. The app which is available in the starter project is very, very simple. We can enter a text into this field, hello, and once we press this floating action button, we're going to navigate to another display screen where the very same text will be displayed. When we navigate back, the text field will be cleared. And when we try to navigate without any input inside of the text field, we're gonna get an error from the form validation. So this is really the extent of the app, and this is the app we're going to be testing in this tutorial. Previously, these kinds of integration tests, which would simulate the behavior of a user, would be written with a Flutter driver package. But now we have the new integration test package, which is just much better. It can, for example, run on Firebase Test Lab. It's even much easier to write. So what more can you ask for? We're going to execute them both locally and also in a more production-grade setup with Firebase Test Lab and Codemagic, so that you can be fully confident that every piece of code you commit to a repository passes the tests on multiple devices, OS versions, screen sizes, orientations, and locales. Whether you have previous experience with the Flutter driver package or not, you're basically both on the same footing, because the new integration test package does not really inherit a lot from the Flutter driver. In fact, the syntax for writing these kinds of integration tests is the same as for writing widget tests. So if you know how to do widget tests, you are good to go. If not, you are anyway going to learn this in this tutorial, right? So the first step we need to take is to add the integration test package as a dev dependency into the pubspec.yaml file. Currently the version is 1.0.1, and this is all that we need to add to the pubspec YAML. Now, the test we are about to write will be executed on an actual device or an emulator. So this means that there simply must be some Dart and also native code in the integration test package that's responsible for making all of the simulated tabs, drags, text inputs, and so on to happen. Later on in this tutorial, you are going to see how to build an Android APK that's capable of running the integration tests fully on its own, which is actually a requirement for running tests on Firebase Test Lab. We're going to be covering only the APK part for Android, but you can also create test files, test app files for iOS, and also test things on the web. We're doing that for time-related reasons, and links to all of the other platforms are in the written tutorial. While we are still inside of our code editor though, it's useful to run the test directly from our machine without the minor hassle of building an APK. For that to happen, we need an integration driver, which we can use to sort of fake the old Flutter driver approach. We can create an integration driver inside of a new folder at the root of the project. Let's call it test driver. And inside of this test driver folder, we are going to create a file integration driver .dart. And inside of there, we're just going to have a future void main, which is going to run the integration driver. Just like that. This is all we need to write inside of this file. If you are familiar with Flutter driver, and again, if you are not, that's completely fine. You're going to learn everything in this tutorial. But if you are familiar with it, this file will be passed into the Flutter drive command as the driver. If you remember how I was verbally describing what the app is going to be doing, so when we input a text, we go to the next screen where this same text is displayed. Then when we go back, the text input is cleared. And when we try to navigate without any text input, we get an error message. Well, this very description is what we are going to be testing. The only thing we'll do is to take that description and take the actions which I was doing manually and transform them into an automatic test, which is written in the Dart language using the widget testing API. The tests themselves should be placed inside of a folder called integration test. And because we are testing the whole app, let's create the file apptest.dart. As with any other tests, we need to have a void main. And even though the syntax for writing integration tests is the same as for writing widget tests, there is one important difference, and that is that we have to call integration test widgets flutter something binding, it's too long, integration test widgets flutter binding dot ensure initialized. This needs to be the first line inside of the main method. While you do not need to know how the app is implemented in order to write an integration test, after all, we are testing from the user's perspective, what you do need to know is this. The page which contains the text input is called typing page. The second page, which displays the inputted text, is called display page. And lastly, the text input field, or text form field actually, has the key your text field. The other things are just implementation details as far as integration tests are concerned. Let's first write a test for when the user doesn't input any text. This is when the error message should show up. So we're going to write test widgets and provide a description and also a callback, which will take a widget tester, async, and that's it. Just a regular widget test. I always try to make the test descriptions convey as much information as possible, and I suggest that you do the same. So we are going to write as the description for this test that not inputting a text and wanting to go to the display page shows an error and prevents from going to the display page. And as always, you can get all of this code, even the one which I have just pasted, this string, from the written tutorial from the link in the description. So what do we want to do here inside of this test? Well, we first need to tell the test with which widget to start, which widget should be displayed on the screen first. We can do that by saying await tester.pump widget, and we want to pump the root widget of our app, which is called my app. So let's do just that. My app. We are testing that we do not input any text and we want to go to the display page. And how do we go to the display page? Well, we want to press the floating action button. So that's what we are gonna do. We're going to say await tester.tap, and we want to tap the floating action button. And since there is only one floating action button, we can find a widget by its type. So find by type, and the type of the button or of the any kind of widget is floating action button. Just like that. And we're good to go. Now we have tapped the floating action button. Now there is one little caveat that we need to be aware of when we are writing these kinds of tests, and that after pressing something which does an animation or it changes something on the screen, we should always wait for that change to finish. So for example, right, when I have a text inputted here, but I press the button, there is an animation as we are going to the next page. In the same way, when there is no text inputted and I press the button, there will be a brief animation while the error text is being displayed. So if anything has these kinds of animations, you should always wait for them to happen and fully finish. So we're going to await tester.pump and settle. As the test description indicates, this single tap of a button is all that the user or the simulated user should do inside of this test. So now comes the time for verifying if everything happened correctly. So we are going to expect that if we try to find the typing page, so find by type, and the widget which we want to find is the whole page, typing page, then we expect that we find one widget. So the matcher will be finds on widget. Why? Well, because we should not have moved to the display page, because if there is an error, meaning that the text field is empty, we should stay on the typing page and not go to the display page. In the same way, we can actually copy this line below. If we try to find a display page or the display page, we should find nothing. So finds nothing. And lastly, when we try to find a text containing the error message, so expect find text, and the error message says input at least one character, like this, then we should find one widget. So finds one widget. We are not going to execute this test immediately, but let's just first actually write the second test as well, which will be testing for when the second page actually appears when the text is inputted. And then when we come back, the text field should be cleared. So let's again write test widgets. I actually have a shortcut for it, so WT like that. And now the description will be: after inputting a text, go to the display page which contains that same text, and then navigate back to the typing page where the input should be clear. I mean, the description cannot get any more descriptive than that. So again, let's first pump the My App widget, and then we want to input a text into the text field. So let's actually write the input text into a final variable, which is going to be called input text. And the text will be as follows. So hello there, this is an input. And again, you can get this code from the written tutorial. Now to enter this text into the field, we are going to say await tester.enter text. The widget into which we should enter the text is the text form field. And if you remember, we can find this text form field by key, and its key is key your text field with dashes in between. And the text which we should input is the input text. Now, after inputting the text, we should go to the display page. So going to the display page again will happen by tapping on the floating action button. So we can just copy it from the test which we have already written. And now is the time for the expectations inside of this second test. So we can actually copy the page widget expectations. But now, for the typing page, we should find nothing. And for the display page, we should find one widget, because the text is actually inputted. Therefore, we should be able to navigate to the display page. We should also check if the display page contains the same text that was inputted on the typing page. So we're going to say expect finds or find dot text, and the text which we want to find is the input text, and we want it to be actually present there, so we say finds one widget. Next, the test description says that and then navigate back to the typing page. So we can do that by pressing the back button up here on the floating or on the app bar. And to do that programmatically, we're going to say await tester.tap, and we want to tap a back button. That's the type of the button which is present on the app bar. So we're gonna say find by type back button. Then again, pump and sell to wait for the animations to, well, pump and sell. And after this, we should be back in the typing page. So for typing page, it should find one widget, and for display page, it should find nothing. And lastly, the input text should not be present anymore in the typing page, because the input field should be cleared out. So we're going to say finds nothing. Now, how can we run these tests on the emulator which is running on our machine, or you can also run them on a device connected through a USB? Well, we're going to use the Flutter drive command. First, let me just stop the app from running regularly, and we are going to open up the terminal and start writing Flutter drive. And we want to specify the driver. So 2 dashes driver is equal to, and the driver is inside of the integration driver file, which we have created first. So test driver slash integration driver dart, and the target file, which means the actual test file which we want to execute, is located inside integration test slash app test dart. Now let's hit enter. The app is gonna be built, and after a while it will appear over here inside of our emulator, and it will run automatically. And also it's a pretty fast process. It doesn't mess around, this tester. It's much faster than a regular user would use the app. So here we go. Test starting, boom, 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 everything has run, and we can see that all tests passed. Great. What we have done now is great. It's much better than the Flutter driver tests, because if nothing more, the syntax is much simpler, because the widget testing syntax is simpler than the Flutter driver syntax. That's just a simple fact. However, if this was really everything that the integration test package had to offer, it would not be that great of a package. What we actually want to do is to be able to run the tests, the integration tests, on services such as Firebase Test Lab. And in order to do that, we need to just have a single APK file, which after it's installed is going to run the tests. Because on Firebase Test Lab, we cannot execute this kind of a command which provides a separate driver and a separate target. It needs to all run just from a single process, from a single app. In the Android world, these kinds of integration tests are actually called instrumentation tests. And basically, we are now going to hook up these cross-platform Flutter integration tests to be run as if they were native Android instrumentation tests. And of course, Firebase Test Lab can cooperate with these kinds of Android instrumentation tests just fine. To set things up inside of the Android folder, inside app, src, let's create two new folders. Android test, actually Android test in Pascal casing, or camel casing actually, and then another nested file Java. Then we want to create other nested folders that will follow the package name of your app. And how to find the package name? Well, open up the main folder inside here. Then if you are using Kotlin as your native language, then open up Kotlin. If not, open up Java, but I'm using Kotlin. And then these three files are, or folders are, com, resocoder, integration test tutorial. So these same folders have to be present, these three, inside of the Java folder. So let's right click, new folder, com, resocoder, integration test tutorial. And of course, you are going to create folders which you have yourself inside of the Kotlin folder. Inside the Android test folder, all the way down in the folder hierarchy, we want to create a new file, main activity test.java, all Pascal cased .java. You see, I start writing D for Dart. I start writing underscore instead of Pascal casing. I'm just, I guess, a full-on Flutter developer by now. But anyway, I would suggest that the content of this file, you are just going to copy and paste it from the written tutorial, to which you can get from the link in the video description, because we are not really writing Java code too much around here, and it's actually just a configuration. There's no real logic present in here. So we just create the main activity test, which is going to be used from the native Android instrumentation tests, and we run it with the Flutter test runner, and then the plugin, which is imported in here, the dev Flutter plugins integration test, is going to do all of its things to make your cross-platform integration tests run as if they were native Android instrumentation tests. Just make sure to change these two lines, the package and also the import of the actual main activity, to reflect your own project. So this com reso core integration testing prep will change to your own package name. The last native Android configuration step is that we will go to the build.gradle file present inside of the app folder right here, and we're gonna add a bunch of dependencies. So also inside of the default config here, we're going to add test instrumentation runner. You can just copy all of this from the written tutorial really. And then inside of dependencies here, we are going to add a test implementation for JUnit, and also Android test implementation for Android X test runner, and also Espresso core and all that. This is just so we can execute the instrumentation tests. With all of this set up, we can now build an APK that's going to run our integration tests as if they were native Android instrumentation tests. But it doesn't make much sense to build it before we set up Firebase Test Lab and Codemagic to automatize the building and testing process. Let's first set up the Firebase Test Lab. Now, to run tests on the Test Lab, you need a Firebase project, but do not worry, because you do not actually need any Firebase dependencies inside of your app. You do not need to use any other Firebase services like Firestore, Analytics, or Cloud Functions. You don't need to add any files to your app directly. In other words, Firebase Test Lab, which we are going to be using here, just does not care if your app uses other Firebase services or not. Now, of course, if you do use, for example, Firestore inside of your app and you have some dependencies inside of your app for Firebase, that's perfectly fine too, but it's not a requirement. You can also use your old Firebase project or create a new one. I'm just going to create a new one. So just go to console.firebase.google.com, and links to all of these websites, which we're going to be going to throughout this tutorial, are also inside of the written tutorial. So the project name will be, let's say, integration test tutorial, just like that. Let's say continue. We're going to disable everything because we really do not need anything special enabled. We are also not going to again configure this inside of the VS Code. We're actually not going to touch VS Code at all. And now the project is ready. Continue. And that's really all there is to setting up a Firebase project when we want to only be using the Test Lab. We do not need to configure anything else. What we do need to configure a bit though is the Google Cloud project, which is associated with this Firebase project, because surprise, surprise, Firebase is owned by Google, so they have these kinds of integrations in between all of their different consoles and platforms. So although we are really working with Firebase Test Lab, we're going to be operating with all the different options we want to configure inside of the Google Cloud Console. So just go to console.cloud.google.com, link is in the written tutorial. And now from this drop down up here, select the project which you have just created on Firebase. So let's search for integration test tutorial right here. Let's select that. Here we go. What we are now going to be configuring is the service account. So just open up the navigation menu here, go to IAM and admin and select service accounts. We're doing this because we are, after all, working with Google Firebase projects. So there is obviously a need for authentication. But because we want to use Firebase Test Lab without any interaction on our part, because we are going to be running this thing from Codemagic, where we just simply cannot click through authentication prompts and, sign up using your Google account, because we are running just from a console from some remote build machine in a data center that the Codemagic operates. And precisely because of the lack of possible user interaction on our part, we need to have a fully programmatic way to authenticate. And when it comes to Google Cloud projects, that's with a service account. So actually, you should already have a service account, at least one, over here for the Firebase admin SDK. You can technically create a new service account just for the purpose of authenticating through Codemagic. But I think, at least for the purposes of this tutorial, it's not going to hurt us to actually use the service account which is already created in here. But if you want to have more granular control over the permissions of the service account, just create a new one. But I'm going to use the one which is already created for us automatically when we set up the Firebase project. And in order to authenticate with a service account, you want to get a key. So click here, create key. We want to select JSON for the key, hit create, and we are going to be able to download a JSON file. Put this JSON file somewhere safe, and also remember where you put it, because we are going to need it later on in this tutorial. Another step we need to take while we are in the Google Cloud Console is to go to this IAM tab and select this first email address, or if you have created your own service account, then select the one which you have for that service account, of course, and edit the member. And we're going to add a role, which is going to be an editor. Like this. Save that, and you're good to go in this regard. Now let's do one more step which is needed from us over here in the Google Cloud Console, and that is to go to APIs and Services from the menu, go to Library, and search for Cloud Tools with a space in between. Cloud Tools Results API, this one. Also, there is a link precisely to over here in the written tutorial, and just hit enable. Once that's done, we have fully configured our Firebase/Google Cloud project to support testing just from the command line on Codemagic. So that's awesome. So how can we automatically run the tests with Codemagic? Well, Codemagic is a continuous integration and delivery service for mobile apps designed with Flutter in mind. And among other things, it's perfect for kicking off integration tests on Firebase Test Lab whenever there is a new commit or pull request in a Git repository. You have 500 build minutes on Codemagic free every month, so you can just sign up and follow along with this tutorial. Link to Codemagic is in the video description, or it's also just codemagic.io. So once you sign up, I would recommend that you sign up or sign in like this with your GitHub account. So GitHub, and select all repositories OAuth. Codemagic is also integrated with Bitbucket and GitLab. And you can also use any kind of a Git repository, even custom hosted ones or from Azure, for example. But for the purposes of this tutorial, I'm going to use GitHub with the all repositories OAuth. Once you're in here, now is actually a good time to create a repository for your project and to also create a remote repository and push your code to GitHub, which I'm actually going to do now. So I have already created a repository, but I'm going to create a new commit saying finished project, as is usual with tutorials over here on ResoCoder. And I'm just going to commit this and push. With this done, we have all of the code necessary on GitHub. So let's go back to the Codemagic. And after searching for integration, I can see that I have this integration test tutorial, which is not yet set up at all. So we want to set up this repository to launch integration tests. So we are going to select a workflow for Flutter. It's going to be a Flutter app. And the first thing we want to do here is to add the Google Service Account key file, which we have downloaded a while ago. While we cannot upload the JSON file simply by uploading the file here, we can add it as an environment variable. But the variable value has to be a simple string. Well, you can convert any kind of file, including JSON files, into a base64 string and then set them up as environment variables. Now comes the question, how do we convert a JSON file into a base64 string? Well, there are very many ways to do that, but I'm going to use the one applicable for me because I'm on Windows and I'm going to be using Git bash. Other ways for Mac OS and Linux are all written in the written tutorial. So if you're interested in your respective platform, just check out the written tutorial from the link in the video description. But now I'm going to open up a file explorer here on Windows, and right here we're going to open up Git bash. So Git bash here. Again, this is just for me for Windows. If you also are on Windows with Git bash, I would recommend this approach. And now we just want to say base64 and provide the path to the file. So in this case, it's in the same folder. So integration test tutorial, blah, 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 the JSON. On Git bash, you are going to be presented with the base64 string printed out to the command line. So let's just copy it all. And now come back to the Codemagic website and create a environment variable with name gcloud key file, although the name is totally up to you, and paste that variable in here, or that string in here, and also tick on the secure option. With secure ticked on, this string will be encrypted and then also decrypted when we try to get it from a script, which we are going to add in just a little while. Now hit add for this environment variable, and we can close this environment variables thing here. Now comes the time to write a script to run the tests on Firebase Test Lab. There are multiple places that you can write your scripts on Codemagic. You can have post-clone script, pre-test script. You can have all kinds of script at different places of the build process. So where should we put the script for running the tests? Well, the answer is we are going to create a post-build script. So hit this plus, and we're going to be writing our script here inside of the post-build script text field. The reason for that is very simple. The documentation of the integration test package says that we should build the app first with the usual Flutter build APK command, which you are all familiar with. That's the usual way to build an app. And only then should we use the more specific commands to build the testing APK, which is going to be running the integration tests. And because we first need to build the app regularly, well, we're going to write this script in the post build script, because the Flutter build APK has been run inside of this build tab. And actually, let me go into the build and disable the iOS platform so that we can speed up the build process a bit, because we don't need iOS at all. And yeah, I guess that's it for the build tab, just to speed things up. And also inside tests, we are now going to enable any tests. You can see that you have Flutter Drive, but actually we are now going to use Flutter Drive from Codemagic like this, because we want to use Firebase Test Lab. So we need to write our own script. Save the changes always. Now this post build script text field is quite handy when you are writing your scripts yourself, but because we are on a video here and you would probably not see anything, because it just doesn't work well with enlarging the UI, as you can see, to 200%. What I'm going to do instead is to write the post build script in VS Code and then just copy it over here. So let's go back to VS Code. I'm just going to create a new file and select bash. Or actually not bash, but shell script, that's how it's called, for highlighting. And let's go ahead and write the script. So we first want to change the directory to be the root of the Flutter project. And since we are on Codemagic's build machine, there is this environment variable fci build dir, which points to the very root of our Flutter project. That's the same root as is displayed here in VS Code. This is where this variable points to. Now we want to go to the Android folder. So we are just going to say push directory, so push the Android. The way to programmatically build an Android test APK is by using this Gradle W script here. So we're going to say /Gradle W app assemble Android test. This builds the Android test APK. And this is precisely why we created that main activity test.java. Now we also want to build with Gradle W a debug APK and pass in the integration test, which we have written as a target. So we're going to say app assemble debug and pass in P, capital P, target, and it's going to be again equal to a string, and we're going to start the path at the fci build dir like this, and then slash. We want to point to the integration test which we have written, so we want to say slash integration test app test.dart slash app test.dart. So that would be it for building the debug app pointing to our test file, and then say push, or actually pubd, sorry, because we want to come back from the Android folder back to the root of the Flutter project. Oops, actually cannot save this file because I'm just going to copy it later. We do not need to save it. Now, if you remember, we have created our own environment variable, the gcloud key file, which contains the JSON key file converted to base64, and it's also encrypted. Now we want to take this environment variable, which we have created, and output it as a regular JSON file into the root of our Flutter project, for example. The way to do that in a script like this is to say echo gcloud key file. So this is our environment variable, and we want to echo this thing into a base64 command. We want to decode now, and we want to decode it into the file at the root of the project here, and the file will be called gcloud key file.json. So now we will have the very same JSON that you downloaded, but we have converted it from a environment variable in base64 back to the JSON file. Once we have that, now comes the time to authenticate with Firebase, or in other words, Google Cloud, with the service account. This is exactly why we need this gcloud key file JSON file. So in order to authenticate with a service account, we're going to say gcloud, the Google Cloud CLI is pre-installed on Codemagic already, which is pretty cool. And we're gonna say auth activate service account. And now we want to specify the key file. So key dash file, and it's present at gcloud key file.json at the root of the project, so we do not need to specify any special paths here. After we are authenticated, Firebase and Google Cloud knows that we are truly who we pretend that we are. Now we need to select the Firebase project on which we want to use the Firebase Test Lab. Now, how do you get your Firebase project ID? Well, if you go to the Firebase console right here and go to the settings, project settings, you have the project ID here in the project settings. Whoops. So for us, it's integration test tutorial. So let's copy that. Copy your own respective IDs, of course. So let's go back to VS Code now, and we want to select this project. So we're going to say gcloud quiet, so that we don't have any prompts or anything, config set project. And now we want to paste in here the project ID, which we have just copied. And lastly, this is truly the last command, is to actually execute the Firebase Test Lab tests. So we're going to say gcloud Firebase test Android run. And now we could just write it inside a single line, but it would be quite, you would not be able to read it, right? In just a single line, it's too confusing. So we are going to put it in multiple lines like this with backslashes. So let's say the type of the tests is instrumentation, new line. The app which we want to run is present at the regular build output for Android apps when you are using Flutter. So we're going to say build /app /outputs /apk /debug /app -debug.apk. So it's right here in the build. So build app outputs apk debug here. Great. Then also we want to specify the test apk. So we can actually copy this thing and cut it off right after apk, because now it's actually present in Android test /debug /app debug Android test .apk. Again, new line here. Actually, I forgot new line in the line above. Now we're good. And this is all that's really needed in order to run the tests on Firebase Test Lab, but you can also add more options. For example, timeout for the test to be 2 minutes. And then you have a plethora of other different configurations that you can provide to this command. For example, you can specify which devices to run this thing on, in which orientation to run these tests, with which locales to run these tests, and you have many different options to choose from and many different devices to choose from. So if you are interested in all of that, there is a link to the documentation in the written tutorial. For now, we're just going to run on the default configuration of Firebase Test Lab, which, if I'm not mistaken, is a pixel emulator, just a single one. But you can easily expand that to run on even 10 or 20 devices in different configurations. But also keep in mind that while you can use Firebase Test Lab for free, there are only, as of now, 5 builds per day for free, and then you of course need to pay. It's not very expensive, but you just need to pay because of course Google needs to make money off of this as well. So just be aware of that. All right, we have written this script in VS Code for simplicity purposes and so that you can see it properly. But now we're going to copy it all, go to Codemagic again, and paste this script as the post build script. Paste it in here. It should all be working fine. Save changes. And now let's scroll up, and you could specify build triggers so that the build gets automatically triggered when there is a new push, pull request update, or tag creation. You can specify all the different branches that these build triggers should be worried about. But for simplicity, we are just going to start our first build manually. So there is only one workflow and one branch, so we can just start new build. And now go get some coffee, have a break, and we're gonna be actually back pretty quickly through the magic of video editing once the post build script is running. So now we have the post build script running after a few minutes of building. So we can actually see what's happening here. Everything is being built, and after some while the APKs which we need are gonna be built, hopefully successfully. I guess there should be no problems. And it wouldn't be a good tutorial without these kinds of blatant errors on my part. So of course, excuse me for that. We need to go back to VS Code, or actually you probably don't need to go back to VS Code, but I do. And inside main activity test.java, I have inputted a wrong package name because I have just copied it from the written tutorial. But here actually the package name is different. It's integration test tutorial. So again, integration test tutorial. This is how it's called, integration test tutorial. And if we take a look at the output from the console or on Codemagic, we can see that this is exactly what's happening. If you can see it on YouTube, we have that cannot find symbol, cannot find the main activity inside of main activity test because, well, we have not imported it properly. But now we did, so we need to commit that again. So fix finish project, fix, whoops, last minute fixes, push, and now we can again execute the build and we should be fine. Start new build, and now it should actually run fully successfully. And here we go. So the whole build process on Codemagic has run, including the post build script. So if we take a look at its output, we can see that there is a bunch of output, but what's important to us is the success messages. So build successful, this is for the test APK. Then we have another build successful, which is for the debug APK, pointing to the target, which is the app-test.dart file, the integration test file. And lastly, we have a bunch of configurations of the Google Cloud project so that we can then upload everything successfully to the Firebase Test Lab. And as you can see, 2 test cases have passed, which is good to see. Actually, when we go to the Firebase console, to the Test Lab tab, we can see this test which has just passed. Clicking on it, we can see on which devices or emulators it has run. As I've said, you can configure this to run on many different devices, many different screen orientations, locales, and so on. But we have just run it on Pixel 2 API level 27. And what's actually nice about this is that you have the standard output of test cases and all that. You can also see the logs if there were any. And it appears that there were some logs. But we also have this video. So we can play that. And again, it's going to be a pretty rapid fire because the tests just execute so fast, but still you can see something. Actually, you didn't even see anything because it's so fast that you cannot even see anything happening on the screen, but it works. So the test case is passed, and that's what's important. That's it for this tutorial, and to go through it at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, link is also in the video description by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you do not want to miss more tutorials like this about testing and about overall Flutter development, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you learn how to write integration tests, how to set them all up, how to execute them on Firebase Test Lab with Codemagic, give this video a like and also share it with other developers who are surely going to find this beneficial too. If you have anything to say, leave a comment, and see you in the next video.